Hi, and welcome to this walkthrough of an acid anhydrides exam question. So I'm going to do a quick review of acid anhydrides first of all, because sometimes they're not comprehensively covered in some textbooks, and they kind of sit at the edge of most A-level specifications. They're mentioned from time to time, but they don't always get the treatment that they might deserve. So this is the structure at the top of your standard acid anhydride. The R groups don't have to be the same as each other. They're carbon-based, but if they are the same as each other, like the one at the bottom, you call it by just the carbon chain. So I'll come on to that in a moment. So the actual active part of the functional group is two C-double bonds bridged by an oxygen atom. So this is called the anhydride functional group. So at the bottom, it would be called ethanoic anhydride, because each of the separate carbon chains is 2 carbons long, including the carbon in the C-double bond O. You don't include the oxygen in the chain, so it's 2 separate ethyl chains you're talking about. So in that way, they're named in a similar way to other carbonyl derivatives such as carboxylic acids. So in terms of structural formulae, what you do is you take the repeating part of the molecule, like this for example, and put it in brackets. If they're different, you have to write them in 2 separate brackets, but in this case obviously there's an ethyl group and part of it is a C-double bond O, and that occurs in 2 separate places. So when you make a acid anhydride, you dehydrate 2 molecules of a carboxylic acid, and that causes them to come together and release a water molecule. They don't have to be the same carboxylic acid because, as we said before, the 2 R groups don't have to be identical. So if we look at some random examples and just illustrate that they can be cyclic, like the ones over on the right, or linear, straight chain, as the ones over on the left. So if we look at ethanoic propanoic anhydride, you can see where the propanoic part comes from. It comes from the slightly longer of the 2 chains. So E for ethanoic, P for propanoic, it gets listed in alphabetical order in the name. So normally cyclic anhydrides are looked at courses beyond A level, so I'm not going to focus on them, and quite often the mechanism isn't actually in the specification as well. But I'm going to have a quick look at it anyway, just in case you're watching and you're doing AQA or another specification where it might be present. I'm doing it from an OCR Chemistry A specific viewpoint. So this particular mechanism, you can see the acid anhydride group there, is called nucleophilic addition elimination, but like I said a moment ago, it's not on the OCR Chemistry A spec. So looking at the reactions of anhydrides, for example, an anhydride reacting with an acid, you can follow where the C-double bond O's go, and obviously the rest of the molecule fits in around them. So let's have a quick look at an exam question. So they start off by telling you that acid anhydrides react in a similar way to acyl chlorides with phenols. So from your recall, you should remember that a phenol and an acyl chloride will give a phenyl ester plus hydrochloric acid. And then benzoic anhydride is the acid anhydride of benzoic acid. So in most A-level Chemistry A courses, OCR that is, benzoic acid comes up quite a lot. So it directs you to the structure of something that should be quite familiar to you. So they want you to show structures for organic compounds using C6H5 for any phenol groups. So I'm going to use structural formulae. So I'll unpack these in a moment for you. But it's benzoic anhydride reacting with butan 2-ol. So this is what's in the mark scheme. But it does allow you any combination of skeletal or structural or displayed formula as long as unambiguous. This is a standard OCR Chemistry A marking principle. So if we look at each of these and then label them up, you'll recognize the names of the compounds mentioned in the question. And we put the structures underneath and then cross-reference them. Okay, hopefully that's been a useful look at acid anhydrides. Thanks always for listening. Until next time, see you soon.